what's also cool that we can do now is we can find the area of a non-right triangle, of an oblique triangle. Now remember what the area of a triangle was? Area equals 1/2 base times height within the right triangle. Well, this isn't a right triangle, but we do know what its height is of this oblique triangle. Remember that the height was the sine of A equaled opposite over hypotenuse, which is h over a b. Solve that for h. H equals b times the sine of A. So if that's being the case now, I know what h equals. So let's look at that in this particular one. So I have the area of this triangle equals 1/2 its base, which is in this case c, times its height, which is modified with b times the sine of A. And then typically you'll see those written down in descending order. So I'm going to rewrite it as b times c. And there we have. The area of a rectangle or a triangle is 1/2 one side times the other side times the sine of A. And we can extrapolate that all the way around to all the other components as well. So this is true. We also know the area is also 1/2 A times B times the sine of C, and also 2A 1/2 A times C times the sine of B. Now we were able to derive those other two by just changing the H. And so I just rotate the triangle around and to form a new base, and that gives me a new altitude and so forth. So what we have here is we have the area of an oblique triangle described in terms of a geometric or a trigonometric function that we are getting used to. So let's look at a triangle here and use what we discovered about the area of an oblique triangle. I have a triangle where I know side, angle, side. C is 24, the angle A is 62 degrees, and the side B is 10. So one of these three should fit the particular areas of what I know. And it looks like I know B and C and the sine of A. So that particular one is the information I have. So the area of this triangle goes 1/2 times B times C times the sine of A. Find the black box to help us with that. 0.5 times 10 times 24 times the sine of 62 equals 105.9 or 106. So approximately 106 square units, where those units were. Okay, so we can find the area of non-right triangles, of oblique triangles, simply by doing this. That's going to open up an entire world for people that need to find areas of odd shapes. I can't wait to see what we can do with this.